This video is for section 16.2 about concentrations of solutions. The learning goals are to be able to calculate the molarity of a solution and to understand the effect of dilution. Let's take some notes on the first learning goal. Be able to calculate the molarity of a solution. One vocabulary word is the word concentration, as it refers to solutions in a chemistry class. Concentration is a measure of the amount of solute that is dissolved in a given amount of solvent. In previous sections, we explored the concept of solubility, dissolving a solute into a liquid solvent. Particles can be dissolved by a solvent when the attractions between the solvent and the solute particles are greater than the attraction between the solute particles themselves. The solubility of a substance refers to the maximum amount of that substance that can be dissolved in a given amount of solvent at a particular temperature. A dilute solution is a solution that contains a relatively small amount of solute. A concentrated solution is a solution that contains a large amount of solute. The word dilute and the word concentrated are fairly vague terms. To be more specific, we need an actual measurement for how much solute is dissolved in solvent. There are different ways to measure concentration of a solution. One method is molarity. The symbol used for molarity is a capital M. Molarity is the number of moles of solute per 1 liter of solution. Here's the math formula for molarity. Let's try an example problem using that math formula. If 500 milliliters of solution has 3 moles of solute dissolved in it, then its concentration is 6 molar. Well, why is that true? How did we know the concentration was 6 molar? By using this molarity formula. M equals number of moles divided by liters of solution. In this example, the value of N is 3 moles. And the number of liters of solution is 0.5 liters, because 500 milliliters is half of 1 liter. 3 divided by 0.5 is 6. And the units that are left are moles per liter. But moles per liter can be represented with the capital M, which means molarity. The way that you speak this is you say 6 molar solution. That number, 6 molar, is a description of how concentrated that solution is in terms of how much of the solute is dissolved in the liquid. Let's say that this solution is 6 molar, but another solution is 12 molar. The 12 molar solution is twice as concentrated as the 6 molar solution. Or consider another example. Here's a 6 molar solution. Let's say that another solution is 3 molar. The 3 molar is half as concentrated as the 6 molar. Here's a check for understanding question. I'll pause the video for you to answer this, and then we'll discuss before continuing on with the lesson. Here's the solution to number 1 on screen. The question asks, what is the molarity of a solution? So I started by writing the molarity formula. M equals N divided by L, where N is number of moles and L is number of liters. I filled in 0.5 moles and 2 liters and then did the division. The result is 0.25 moles per liter. But a faster label for moles per liter is a capital M, 0.25 molar. All year long, when we've done labs that have used chemicals, I have written the molarity of each chemical that you've used on the bottle or the beaker. When you think back to all of our labs, you might remember some of those molarity values that were written on containers. We frequently used 0.1 molar solutions of things. When we used acids and we wanted to have a pretty strong acid, we frequently used 6 molar acid. Here's the next learning goal. Understand the effect of dilution. Diluting a solution is the process of adding water to create a less concentrated solution. A helpful formula is M1 times V1 equals M2 times V2. Here are the meanings of each of the four variables. The idea is if you begin with a solution that has a particular molarity and you use a particular volume of that solution, you can add water to it to create a greater volume of a less concentrated solution. Let's try an example problem to see how that formula works. Explain how to prepare 300 milliliters of a 0.2 molar sodium chloride solution if what we have to begin with is 1 molar solution from our stockroom. Let's follow the problem-solving strategy we used with the gas law problems to label variables here. We want to create the 300 milliliter solution from solution that we already have in our stockroom. This is our new volume. This one is V2. So even though it's the first volume written in the story, when we interpret the meaning of what this is asking us, this is V2. This value is M2. This is the molarity of the solution we want to create. It's not the molarity we're starting with. We're starting with the 1.0 molar solution that's in the back supply room. This is M1. Nowhere in there does it specifically say V1, but that's the variable we don't know. So let's use the dilution formula to find the volume of that original stockroom solution. M1 times V1 equals M2 times V2, and we'll make our substitutions. For M1, it's 1.0. We don't know volume number 1. That's kind of what we're asked to figure out. How much of this original solution from the supply room do we need to use? For M2, that's 0.2. And for V2, it's 300 milliliters. Let's use our algebra skills to solve the equation for V1. Notice you're going to divide both sides by 1.0. When you divide by 1.0, it's not actually changing the value of anything. So let's go 0.2 times 300. The result is 60. We were finding a volume, and the other volume was in milliliters, so it makes sense that this is in milliliters. Now, just because we got an answer for V1, that doesn't mean we've answered this question. This question is looking for an explanation. Explain how to prepare the solution. Just saying 60 milliliters, that doesn't explain anything. So we need to continue on. A sentence like this would do it. Now we have an explanation of how you could actually accomplish this in a lab experiment. Do you understand where the 240 milliliters of water comes from? We want to end up with a volume of 300 milliliters, and we're starting with 60 milliliters of a solution. 60 plus 240 more would make the 300 milliliters that we want to create. Can you imagine actually doing this? In our back supply room, we have sodium chloride solution that has this concentration. And for a lab, we need 300 milliliters of this weaker concentration. You would take a container, pour in 60 milliliters of the 1 molar solution, and then you'd measure out 240 milliliters of water so that you could mix it in with the 60 milliliters. Here are some check for understanding questions. I'll pause the video for you to answer these, and then we'll discuss the solutions. Here's the solution to problem 1. How many milliliters of 3 molar potassium chloride solution are needed to prepare 200 milliliters of 0.5 molar potassium chloride solution? When it asks us how many milliliters are needed, that's volume number 1. The 3.0 molar is molarity number 1. Now we're trying to prepare a new solution, so this number is V2, and this new molarity is M2. I've written the formula M1V1 equals M2V2 and made the substitutions. Dividing by 3.00 on both sides, we'll get the V1 alone. And the result is 33.3 milliliters. Here's number 2 solution. Explain how to prepare 1 liter of 0.1 molar silver nitrate solution from a bottle of 0.5 molar solution. We want to prepare the 1 liter, so that's going to be volume 2. We want the solution we prepare to have this molarity, that's M2. This number here is our original molarity. It's what we're starting with. And it doesn't explicitly even mention the thing that will be V1, but that's what we need to figure out. So I've written the dilution formula M1V1 equals M2V2 and made the substitutions and solved for V1. The result is 0.2 liters. This question asks for an explanation, so let's do a sentence. To create this solution that we need to use 0.2 liters of the 0.5 molar solution and then add to it 0.8 liters of water. Here's how I got the 0.8 liters of water. We want to end up with 1 liter when we're done. And we're starting by using 0.2 liters of a solution from our supply room. 1 subtract 0.2 is 0.8. To make up the difference, we need to use 0.8 liters of water.